All right. Well, I actually have the question up right now. I said I had the question up right now. I don't have I can't see your screen, but I have my lecture slide. So which question is it? All right. So basically, it came from the fact that the idea about buoyancy is that the weight of the log is going to displace an equal amount of weight for water, right? So if we take our equations for weight being rho vg, that means we can set the two weights equal to each other. That's when it's like stabilized. Like if an object is submerged in water and it is freely buoyant, then that means like there's no like extra force. It's not being pushed down. It's displacing an equal amount of water. So I think in this case, the log was 1,000 kilograms. So 1,200 kilograms. So it would displace 1,200 kilograms of water when it's in equilibrium and it's floating. Well, so like the idea is that when the whole idea about buoyancy is that when you submerge an object into some sort of fluid, liquid, or even like a gaseous fluid, uh, you end up causing the fluid to get pushed to the side, and that causes the fluid to end up with a pressure difference, and that pressure difference will end up resulting in a force that happens to be equal to the amount of weight that you just pushed aside of the liquid, or of the fluid, I should say. Well, it would have to be equal to that. So, like when you put the log into the log is going to end up floating because the water that gets displaced will end up equaling that 1,200 kilograms. If you actually look at the slide right before, I give the scenario where you fully submerge the log under the water. So like you take the log and you kind of like pull it down so that it is fully submerged, and in that case, the entire mass of the log is 1,200 kilograms. But when you actually try to figure out how much mass of the water was displaced based off of the density of the water and the volume of the log, then you end up getting that the mass displaced was 1,200 kilograms. So it shows that you displaced more liquid than there was log. Sorry, I don't know why I've my internet keeps dropping. Yeah, so this might keep happening. I think it might be raining by me, but I don't know. So yeah, so what we end up having is that the weight displaced, like the amount of fluid that was displaced, is more than how much the object weighs. So that resulted in the buoyant force pushing the log up, and that's why we were able to tell that the log floated.
No, it's equal to. Yeah, when it floats. Exactly. Like I said, in the slide right before at 32, slide 32, this was a scenario where the log was fully submerged in the water, and because of the mass being greater, that showed that the buoyant force is going to push up the log so that it was floating. So like basically, if you fully submerge an object in the fluid, and the fluid's mass is greater than the mass of the object, then that's going to tell us it's going to float. However, it's not going to tell us enough of how much it's going to float, like whether it's going to just barely be at the top, or is it, 90% out of the water. Does that make sense? Yeah, that's more for like extra information, just to let you know about things that you might see in later classes. Because if you continue in physics or even engineering, after the intro course, they're going to rehash all these topics, but in more detail. And those viruses, they're going to go into detail about them. So I just want to kind of give you an idea of what like things like for example, on the fluids, there's viscosity that's got the virus. Um, and that's going to end up being kind of the something that you're going to talk about in the later parts. No, unfortunately, I don't have the ability to do that. So what you're going to do is you're just going to log into Blackboard. You're going to pull up the question that pops up, and then you'll work on it. There's no other program, nothing else that you'll have to do. It's just go to Blackboard, look at the answer the question that shows up, and then once it gets auto submitted, you're going to, as quickly as you can, upload it through Google Classroom. Okay. If you have any follow-up questions, let me know. I don't think that Edpuzzle has a method for that. Um, honestly, yeah. So what I would recommend is what you could do is you can watch it on YouTube and then just go back and answer the questions in it on Edpuzzle. It'll say that it's incomplete, but I'll be able to see that you've answered the question, so it'll be fine. Like I said, it's just meant strictly as a attendance purpose. Sure. I mean, not yeah, it wouldn't be too hard, right? Because you can. I'm pretty sure you can skip an Edpuzzle. I didn't lock skipping, so you could just kind of go in, skip over to the questions, type in the questions, and it'll be you know done in a few seconds, right? Yeah, because I mean, if you're gonna have if I did lock skipping and you had to watch it all the way through, I would have said unfortunately try to watch it on Edpuzzle, but I didn't do that because again, I'm not trying to baby you guys. The point of the Edpuzzle is really on your end, like for as I've said before, a person could come in, you know, skip just to the questions, write a random thing, just so they get the submission of this was completed. But all that does is really hurt themselves. So that's why it's like up to you to decide. If you're still watching the videos but skipping ahead, like that's in my mind that's just as good as watching it normally on Edpuzzle and then answering the question. Yep. Yeah, doesn't affect the grade at all. That's pretty much like showing the work. So for example, um, you know, writing things like uh, FB equals rho VG, FB equals, and then you plug the numbers in, and FB equals 500 newtons. The work that you did before, where you showed what your base equation was and the numbers that got plugged in, that's the explaining. Basically, I shouldn't look at your work and think, where did that number come from? Where's he getting these equations from? If you jump straight into, let's say if you look at the practice exam. So it was the first practice exam. So for example, if you look at the practice exam part A, where it says what's the tension in the horizontal cable, if you somehow went straight into doing TC, the very last equation, TC equals half force of beam plus F crate times B over A. Where did that equation come from? What's the explanation? Like, how did you somehow figure that out? Uh, Everything, all these other equations, those are the explanations. Showing me that you started with the concept that torque was equal to zero because it's in equilibrium. Knowing that torque is uh, force times distance times sine of theta. That's part of the explanation. So like showing that how you're using the equations to lead you to the answer, that's what I meant by explaining. Well, I mean, it should start with the general formula. Like, when you say something like, I'm trying to think of a good example. Okay, so a perfect example would be when you're using the Bernoulli's, right? So Bernoulli's has a variation. Uh, I want to get the name right just because I keep forgetting the person's name. Right? But in fluid mechanics, I actually had already had it up before. It was so Bernoulli's equation is that whole equation with the pressure plus the kinetic energy plus the potential energy is constant, right?
but then you have I can't find it. I don't think I have it on here. I think it's one of the homework questions. It's a variation of Bernoulli's for a water coming out of a spigot. Oh, Torricelli, that's it. Torricelli's equation. So Torricelli's equation is essentially a variation of Bernoulli's, but it only works in very specific case. In the case of you have one end that the water is moving with zero velocity. You have another end that's open, and both sides have the same pressure. Uh, and if you don't have all those boxes checked, then you can't use Torricelli's theorem. So if you're going to do a question that basically had something like a you have a vat with a spigot open at the end, I'd want you to show that you knew that you have to use Bernoulli's, and then you would say, okay, well, pressures are equal, so we can drop them. This is zero because it's, they say that V1 zero, and then you can say now I can use Torricelli's. Pretty much, yeah. Like I said, I am an AP teacher, so it makes a lot of sense for me to keep that style in there. Yeah, yeah, I'd want to see the numbers. So there actually is logic. It's not just because of the fact that it's similar to what AP does, and that's why. The other reason is because, for example, if you don't get into that habit of writing the base equation, you just instead, just start using derived equations. A lot of times, what ends up happening is people will end up essentially using equations that don't match the scenario, and it's essentially just shoving round pegs into square holes where they're just kind of forcing the setup together. You know what I mean? Like, if you see this question where there's like I keep going with the vat just because it's the one that pops in my mind. Where you have a vat that's open at two ends and the water's coming out, and you want to figure out how fast it's going, and you immediately just start using Torricelli's. Well, that's great, but that doesn't work with every vat. That only works with some vats. So you're limiting yourself, and you're actually not showing that you fully understand the equation because you're trying to use it in a scenario that doesn't work. So that's why I want you to prove that you are supposed to be using that by showing the equation and then showing that you understand that, this is where the equation's coming from. And it's because these variables get dropped out that I can rewrite it to get this Torricelli variation. Same thing with the numbers. Sometimes it's really hard for me to understand, like you get an answer, right? Uh, and even if you just show me like, oh, I'm essentially using torques, all right, but if I don't know what numbers you're using and I can't see where the mistake is, it's really hard for me to give you any partial credit. And that's kind of where a lot of the points are. You have a question that's worth 3 or 4 points. That's because there's a lot of things that you have to do in between that I want to make sure that you are hitting so I can give you the points. If you just say, oh, I'm using, the torques are equal and I got 2.3 meters as my answer, and that's not the correct answer, well, then I don't know where you went wrong, and I can't see whether or not you deserve any points. Does that make sense? Yeah, and you should also try to also, like I said, show like the step progression. I know it seems like it takes a lot of time, but once you get into the habit, it just becomes second nature. Like for example, I'm looking at your question 4A. Um, you did you did show the numbers. I don't need to see the units in that. Everything's pretty much fine. The only thing I would have said is I probably would have liked the in between step saying that tau one is mgr equals mgr. Just like that. So I can understand like the progression again. Uh, you got it right. So obviously, I can understand what the progression is, but not everyone gets it. That's I mean, for the homework, no. For the homework, I'm not really looking into that. Like I said, I don't grade it that detailed. I don't have enough time. I'm basically just looking to see whether or not the work that you're doing is making sense. And if it's not, then you lose the point or you lose a point. So this is fine enough for homework, but on tests, you just want to make sure that you show the progression. It's like, okay, I'm starting with the torques being equal. I know that, and then I can say that, well, that's FR equals FR. Yeah. Not to nitpick, I probably would have started with sum of torques equals zero or tau n equals zero. Just that's always a really good basis, but I probably would accept either one of those as actually. Let me look at what I did for the practice tests. Yeah, I would say try to get into the habit of showing that. Mainly because again, I want to see that you're understanding where everything's coming from. Because again, there's been so many times when I'm looking at these tests and I'm looking at the solutions, and like I said, people are forcing the round pegs into square holes in the sense of they're starting with equations and they're ignoring like they go straight to tau equals tau and they completely ignore that there's a third torque, right? Or they ignore the angles that are involved, and they just kind of like are skipping steps that had they started right from the beginning and said like, okay, some of the torques equal zero and these are my torques, okay, these torques are equal to each other, it would have like helped them out a lot more. Yeah, yeah. I would allow that if it's not at a specific angle where it's 90 degrees, you can immediately drop it or simplify it a bit. That's perfectly fine. Obviously, for going back to Bernoulli's, just because that's an equation that's really long with a lot of things that will end up dropping out. That's one that I wouldn't want you like immediately simplifying. I'd want to see that full equation again, and then you just have the crosses on all the things that are being dropped, and then the next line could be the simplified version. Like I said, if you want to see a good example, the practice solution, uh, I do sort of go into a little bit more than I need, but that's pretty much what you should be trying to hit. Um, so in the practice solution, like I said, finding the tension in the cable, I wrote like, okay, well, you have to do the sum of the torques equals zero. That led us to the torque of the cable is equal to the other torques, and then you could substitute the tr sine theta for all, or force times r times sine theta for all of them, yada yada yada. And you could see like how if I even if I got rid of the words are only there for me to know like what I'm looking for. If you get rid of the words, it's very easy to follow what I'm doing in the logic between each step. You know what I mean? I think it's 6 and 8. Yeah, I'll post. I'll have to try to remind myself to post it on Monday. But I'll post something just as a quick reminder about the test. But it says it in the description, so when it finally does open up on Blackboard, it says what the range is. And I'm pretty sure it says you can start it at any time between 6 and 8:15, but you're gonna want to try to start before 7:15, only because I can't guarantee that if you start after 7:15, it may auto close before the hour. I mean, it might not. It might let you go because I know it's gonna make it so that no one can open up the test after 8:15. So it closes on that end. I just don't know if it is going to also close on the end of the people already starting. Yeah, so I recommend that you start somewhere between 6 to 7. But if something happens, like for those who were having trouble getting, because something came up, time just wasn't on their side, and it's now 7:30. I don't want them to their hands up and say, oh, I missed the test. So, obviously, you know, in that case, you feel free to start it because I'm pretty sure it shouldn't auto submit, but I can't remember. Someone showed up before.
Um, I'm recording this right now, which is actually why it took me a while to respond. Uh, so you can watch the questions they asked. No problem. You too. See you later.